going on, besties? In this video, we're going to talk about everything you are going to need to know when it comes to solving word problems on the ATI TEAS. Are you ready? Let's get started. So as you can see on your screen over here, this is a little cheat sheet of everything that you're going to need to know in regards to how to translate words into algebraic expressions. So let's go over those crucial expressions that are going to be pivotal in solving algebraic word problems. So when you come across the phrase 4 times a number, you're going to automatically translate this into 4 times x, where x is going to represent that unknown quantity that we have to figure out. For expressions like 4 more than a number, that is translated into x plus 4. Something to make sure you have careful attention to is when you see things like 4 less than a number. It can be easy to interpret this as 4 minus x, but that's actually incorrect. The correct translation is x minus 4, despite that initial position of 4 in the sentence. So be very careful when you come across word problems like this. For a phrase such as 4 times the difference of 2 numbers, it's understood that 4 is going to be multiplied by the difference between x and y, or it's going to be 4 parentheses x minus y, highlighting the importance of placing that x minus y within parentheses and the 4 on the outside. When you see terms like sum and mentioned within our word problem, we automatically associate that with the sum of 2 numbers. So this can be written as x plus y. In contrast, the difference between 2 numbers would be x minus y. If you encounter words like product of 2 numbers, it's going to refer to the multiplication of x and y. And then lastly, if you see words like is or equals, that's just a fancy way of saying our equal sign. These expressions are going to be fundamental when it comes to algebra and mastering that translation into mathematical terms to effectively solve your word problems. Let's take a look at some examples. So our first practice question is, if 6 more than a number is 14, what is the number? So let's break this down, starting from left, working our way to the right. So 6 more than a number is x plus 6. So then we have the word is. Is just, of course, just a fancy way of saying our equal sign. And then lastly, we have 14. And of course, 14 is going to be 14. So now we just need to put our problem together. So we have x plus 6 is equal to 14. Now we just need to solve for x. So we do so by minusing 6 from both sides, and that is going to give us x is equal to 8. Our next example states 3 times a number equals 45. What is our number? So again, we're going to break it down. So 3 times a number is going to be 3x. Then we've got equals, it pretty much just tells us what it is, right? Equals is equal to equal sign. And then lastly, 45, again, 45 is just 45. So now we just need to put our equation together. So we have 3x is equal to 45. We need to isolate our x in order to find the number. So we're going to divide both sides by 3, and that is going to give us x is equal to 15. All right, now that we get the hang of this, let's see if we can figure out these more complicated problems. So we're going to start off with, again, solving our equation from left to right, breaking it down. So 5 times the difference of 2 numbers is 35. If one of the numbers is 10, what is the other number? So again, we start with 5 times is the difference of 2 numbers. So that is going to be 5 with parentheses x minus y. So we've got our first part. We have the word is, so that is our equal sign. And then we have the word or the number 35. Well, it also tells us one additional thing, right? It says one number is equal to 10. So that gives us our new equation. So we can say 5 parentheses x minus 10 is equal to 35. Now we just need to solve. So in order to solve this, we have to multiply our 5 by everything within inside our parentheses. So we're going to multiply 5 by x, and we're going to multiply 5 by 10. So we've got 5x minus 50 is equal to 35. Now we need to start isolating our x. So we are going to add 50 to both sides. That is going to give us 5x is equal to 85. And now we are going to divide 5 by both sides in order to isolate our x. And that is going to give us x is equal to 17. Not too bad. So our next question states the product of 8 and the sum of a number and 2 equals 64. What is our number? So let's break this down working left to right. So the first thing we have is we have the word product. So as we know, product is going to be our x and it's going to be our y multiplied together. So we know that we have the product of 8, so that's the start of our equation, and it's going to be the sum of a number and 2. So that's going to be x as our number plus the number 2, and we're going to close our parentheses sign. Next, we have the word equals. So of course, equals is equal to equal. And then lastly, we have the number 64. So 64 is 64. So now we're going to do the same thing like we did before, and we're going to multiply our 8 by everything within our parentheses. So we're going to multiply 8 by x, and we're going to multiply 8 by 2. So that's going to give us 8x plus 16 is equal to 64. Now we need to start isolating our x, right? So we're going to minus 16 from both sides. That's going to give us 8x is equal to 48. And then we are going to divide 8 by both sides to isolate our x. So x is going to be equal to 6, which is the answer to our word problem. So let's work on a little bit of a longer word problem. So this word problem states a hospital uses 2.5 liters of sanitizing liquid across 5 examination rooms every day. If a bottle of sanitizing liquid contains 500 milliliters, how many bottles are used per day? So first, right off the bat, I'm just going to eliminate the fact that we have across 5 examination rooms every day because it has nothing to do with our problem. So we're solely focusing on the fact that we have a use of 2.5 liters of sanitizing liquid and the fact that each bottle contains 500 milliliters. So we have to figure out how many bottles are used per day. So the very first thing when we're looking at this problem is that we have liters and we have milliliters. So we're going to have to convert our liters to milliliters in order to solve this equation. So again, if you haven't watched the metric conversions, highly recommend that you watch it so this makes sense. So 2.5 liters is equal to 2,500 milliliters. So now we're just going to plug and play. So we know that we have 500 milliliters, and that is going to be multiplied by B because we need to know how many bottles we need, right? And that is going to be equal to 2,500 milliliters. This is our equation. We have 500 milliliters per bottle. That's represented by the B that we added into our equation, and it's going to be equal to 2,500 milliliters. Now all we have to do is isolate our B. So we do this by dividing both sides by 500, and that is going to give us B is equal to 5 bottles. So they need a total of 5 bottles in order to make it through every day. Our next question states, Sarah trains for a marathon by running 15 kilometers every day. If a marathon is 42.195 kilometers long, how many days of training does it take Sarah to run at least the distance of a marathon? So we have 2 numbers here. We know that she runs 15 kilometers every day. And then our second number is we know that a marathon is 42.195 kilometers, and we need to figure out how many days it's going to take Sarah to run this. So we're just going to plug this into an equation. So we're going to have 15 kilometers over 42.195 kilometers is equal to 1 day over X day. So what I like to do when I'm doing word problems, especially proportions and ratios, is I like to keep the same terms on each side. So on this side, we know that these are the kilometers that she's going to run. And on this side, well, this is the time, right? How many days? So this is like I had to kind of keep it simple and to keep it organized. So as always, we're going to cross multiply. So we're going to do this by cross multiplying our numbers. That's going to give us 15x is equal to 42.195. And now we're just going to divide each side by 15 in order to isolate our x. And that is going to give us 15 is equal to 2.813 days. Or if you were required to round up, it's approximately 3 days. So the correct answer is 2.813 or 3 days. So next up, let's talk about percent proportions, where relationships between a part and its whole matches the relationship between percent and 100. This allows us to create an equation or proportion to represent that relationship. So the formula that we are going to use, as you can see here, is over of is equal to percent over 100. With this formula in hand, we can tackle a lot of problems focusing on percents. Let's take a look at our examples. So looking at our first practice question, we have 18 is what percent of 42? So we break this down. We have our is, that's 18. We're trying to figure out what a percent is because we have the words what percent, and we have our of, which is of 42. So now we're just going to plug in our numbers. We have 18 over 42 is equal to what percent, right? So that's going to be our x over 100. Now we're just going to cross multiply. So we're going to multiply 42x is equal to 1,800. We need to isolate our x by dividing both sides by 42. And that is going to give us x is equal to 42.86%. So moving on to our next question, we have 20 is what percent of 45? We're going to use the same formula. So we have our is, that's 20. We're trying to figure out what percent, that's our x. And then lastly, we have 45. So now we're just going to plug in our numbers. So we have 20 over 45 is equal to what percent, that's our x, over 100. So now we're just going to cross multiply. So we're going to multiply here, we're going to multiply here. That's going to give us 45x is equal to 2,000. Then we're going to isolate our x by dividing both sides by 45. And that is going to give us x is equal to 44.44%. And now with our last initial example, we have what percent of 12 is 27. So this one's a little bit different, right? Let's just break it down working left to right. So we have what percent, that's our x, that's what we're looking for. 12, so that's our of, is 27. So now we just need to plug in our numbers. We have 27 over 12 is equal to x over 100. Now we're going to cross multiply. That's going to give us 12x is equal to 2,700. We're going to divide both sides by 12. And that is going to give us our answer of 225%. Let's take a look at some longer word problems when it comes to percentages. So our first problem is, in a town survey, 250 people said they prefer tea over coffee out of the total 500 respondents. What percentage of the respondents prefer tea? So again, we're just going to work this out working left to right. So we know that our is our 250 people. Those are the people that prefer tea over coffee. Our of is the total amount of people that were surveyed, right? So that's 500 respondents. And then what percentage of the respondents prefer tea? So again, what percent? That is what we are looking for. That is our x. So now we're just going to plug in our numbers. 250 over 500 is equal to x over 100. Now we're going to cross multiply. So we're going to cross multiply here and cross multiply there. That's going to give us 500x is equal to 25,000. We're going to divide both sides by 500 in order to isolate our x. And x is going to give us 50%. Our next example states a store sold 120 out of 150 chairs they had in stock. What percentage of the chairs were sold? So again, we're just breaking this down. So working left to right, a store sold 120. So that is our is. Out of, there's our word of, 150 chairs. What percent is what we're looking for? That's our x. So let's go ahead and plug this into our equation. We have 120 over 150 is equal to x because we're trying to figure out what percent over 100. So now all we have to do is cross multiply. That gives us 150x is equal to 12,000. We're going to divide each side by 150, and that is going to give us x is equal to 80%. So 80% of the chairs were sold. Now let's take a look at word problems using ratios and proportions. So ratio and proportions are problems that are one and the same, and they can be solved with the same cross multiplication that we've been using this entire video. So starting with our example, we have Carmen can read 4 fictional books in 10 hours. Assuming all the books are the same length, how many hours would it take her to read 50 fictional books? So step 1 is we want to identify our knowns and our unknowns. So what we do know is that Carmen can read 4 fictional books in 10 hours. We know that, right? What we don't know is how many hours it's going to take her to read 50 fictional books. So our knowns are she can read 4 fictional books in 10 hours, and we're trying to figure out how long it's going to take her to read 50 fictional books. Our unknown is that amount of time that it's going to take her to read those 50. So for step 2, we need to plug in our proportions into our equation. So we have 2 proportions, and I've written them out here. We have 4 books in 10 hours, and we have 50 books in X hours. So like I said before, what I like to do is keep everything organized. So on the left side of our equation, I have all of our books, and on the right side of our equation, we have our time. So what I did is I plugged in 4 books into our numerator on the left, and 10 hours into our numerator on the right. On the bottom, we're trying to figure out how long it's going to take her to read those 50 books. So I put 50 books underneath our 4 books in the denominator on the left, and I put X hours, which is what we are trying to figure out, in the denominator under our 10 hours numerator on the right. So now all we have to do is we have to solve for the proportion. So we use that cross multiplication that we've been doing. So we would have 4 times x would give us 4x, and we have 50 times 10 would give us 500. And then of course, in order to isolate x, we would just divide each side by 4, and that would ultimately give us x is equal to 125 hours. Let's take a look at some examples of this in real time. So our first problem states the ratio of boys to girls in a class is 8 to 7. If there are 48 boys, how many girls are in class? So what we know is we have an 8 to 7 boys to girl ratio, and we have 48 boys. What we don't know is how many girls are in the class. So that's what we're trying to figure out. So like I said before, what I want to do is organize everything it is that I need to know. So I'm going to put the boys on one side, and I'm going to put the girls on the other side. So I know that there is a 8 to 7 ratio of boys to girl. Those are going to be my numerator on both sides of my equation. I know that I have 48 boys. What I don't know is how many girls I need. So now that I have my equation, it's again just a sense of cross multiplication. So that's going to give us 8x is equal to 336. We need to isolate for x on both sides by dividing by 8. And that is going to give us the number 42. So we know we have 48 boys in class, and the number we didn't know is now we have 42 girls in that class. Our next example is Calvin can make 16 cakes in 8 hours. How many cakes can he make in 16 hours? So again, what do we know? We know that Calvin can make 16 cakes in 8 hours. But we don't know is how many cakes he can make in 16 hours. So we're just going to plug this in. Again, organizing it. I like to keep everything organized. We're going to put cakes on one side, and we're going to put our time on the other side. So starting with our ratio, we have 16 to 8, right? So we're going to put 16 in our numerator on the left, and we are going to put 8 in our numerator on the right. And now we know at the bottom, he needs to make a certain amount of cakes within 16 hours. So we know what the hours is on the bottom. We just need to figure out how many cakes he's going to be able to make. So now that we have our equation, we're going to cross multiply. And we do this by saying 8x is equal to 256. We need to isolate our x on both sides by dividing by 8. And that is going to give us x is equal to 32 cakes. So within 16 hours, Calvin should be able to make 32 cakes. So in a hospital ward, the ratio of nurses to patients on a particular day is 1 to 4. If there are 8 nurses on the ward, how many patients are they going to be responsible for? So we know we have 8 nurses, and we're trying to figure out how many patients they're going to have. So again, we're going to organize it. So we're going to put our nurses on the left, and we're going to put our patients on the right. And we're just going to plug in our ratios. So we have 1 nurse to 4 patients. We know that we have 8 nurses. We're trying to figure out how many patients they're going to have on the floor. So again, we're going to cross multiply. That is going to give us x is equal to 32. There's no additional math that needs to take place, so we know that if we have 8 nurses on the floor, we should have 32 patients as well. So here's a really good one for those of you who are going to nursing school. So a prescription requires medication to be given at a ratio of 2 milligrams per 10 kilograms. That's our first ratio. If a patient weighs 70 kilograms, how many milligrams is that patient going to receive? So again, we're going to organize our information. We're going to put our med here on the left-hand side, and we're going to put our kilograms, which is our patient's body weight, over here on the right-hand side. And we're just going to plug in our ratios. So we have 2 milligrams of med for 10 kilograms of patient. We know that we have a 70 kilogram patient, so we need to figure out how much med they're going to receive. And now we're just going to cross multiply. So that's going to give us 10x is equal to 140. We're going to divide each side by 10 in order to isolate x, and that is going to give us x is equal to 14 milligrams. So for this patient, we need to make sure they get at least 14 milligrams based on their body weight. Next, let's talk about rate, unit rate, and rate change. I group these concepts together with ratio and proportions because they follow the same principles. So rate is essentially a ratio that illustrates the connection between 2 quantities with different units, effectively demonstrating how one quantity relates to another one when the units are going to differ. Whereas with a unit rate, this particular form of rate is going to be where the denominator is 1 and it is essentially expressing the same amount of a single unit. So let's explore how each example clarifies this concept. So with our first example rate, we have 36 miles in 4 days. How many miles per day? So again, we organize by putting our miles on one side and we put our days on the other side. So we know that this individual is going to be able to drive 36 miles in 4 days. That is our first ratio. Our next ratio is how many miles per day. So we know that we have 1 day and we're trying to figure out how many miles. So we plug this into our equation and of course we're going to cross multiply. So that's going to give us 4x is equal to 36. We need to isolate x in order to figure out our equation. So we're going to divide 4 by both sides, and that is going to give us x is equal to 9 miles per day. Next up, we have unit rate, and we're usually talking about unit rate, we're talking about money. So in this case, we have $96 in 8 hours. How many dollars per hour? So we know we get $96 in 8 hours. Now we've got to figure out in each hour, how much money am I getting? So we're going to go ahead and plug that into our equation. Remember, keep everything the same. We're going to have dollars on one side, and we're going to have hours on the other side. And we're going to get 96 over x is equal to 8 over 1. We're going to cross multiply. That's going to give us 8x is equal to 96. We have to isolate x, so we're going to divide each side by 8, and that is going to give us x is equal to $12 per hour. So how do we solve word problems with inequalities? So inequalities is a mathematical expression that describes relationships between two values when they are not even. So instead of saying two values are exactly the same like we do in equations, inequalities is going to tell us if one value is greater than, less than, greater than or equal to, or less than or equal to another value. This helps us understand the range of limits within a certain quantity that can exist. There are four main symbols that you're going to see when it comes to inequalities. First up, we have the greater than symbol, and that's going to indicate that the value on the left side is larger than the value on the right side. Next, we have the less than symbol, and this is going to indicate that the value on the left side is smaller than the value on the right side. Next, we have greater than or equal to, and that's going to indicate that the value on the left side is either greater than or equal to that value that's found on the right side. And you've guessed it, you're right, that less than or equal to is the exact same thing. It's going to indicate that that value on the left side is either less than or equal to the value on our right side. So here's a quick tip for remembering less than and greater than signs. Think of each sign as either a hungry, hungry hippo or a Pac-Man, or for me, because I live in Florida, I always think of an alligator. They're all hungry, right? They all want to eat as much as they possibly can. So their mouths, if you think about that little sign as a mouth, is always going to eat the greater number, right? So it's either going to be greater than or it's going to be less than, depending on which way they're eating it. So hopefully that kind of helps trigger your memory when you're trying to figure out which one is which. So let's take a look at our first example. We have a hospital elevator has a maximum weight capacity of 2,000 pounds. If there are already 3 people on the elevator with a combined weight of 460 pounds, write an inequality expressing the possible weight that may be added to the elevator. Use W to represent the weight. So we're given that the elevator has a max capacity of 2,000 pounds. That's the total amount of weight that can be in that elevator, and you cannot go above that threshold. So in scenarios where we're dealing with maximum limits, the appropriate mathematical symbol to use is going to be less than or equal to, because the total weight can reach up to 2,000 pounds, but it's not going to be able to surpass it. So we either have to have less than or equal to what that weight is. Next, we want to make sure that we add our weight, so we know that we have 2,000 pounds is going to be acceptable. Given that there are 3 people already on the elevator and they have a combined weight of 460 pounds, we actually have to incorporate that within our equation. So I'm going to add 460 over here to the left side of the equation. And then of course, we have to incorporate W, because W is going to denote what that weight is going to represent for that additional weight to not exceed that 2,000 pounds. So that's going to be W plus 460 is less than or equal to 2,000 pounds. Now we just have to solve our equation. So we're going to minus 460 from both sides in order to isolate W. And that is going to give you W is less than or equal to 1,540 pounds. So at most, the most that they can add to that hospital elevator is going to be 1,540 pounds with those additional people that are already on the elevator. Our next example states, to qualify for a scholarship, students must score at least 85% on their final exam. If X represents the student's score on the final exam, which inequality represents the score of students who qualify for the scholarship? So as we know, these students have to have at least 85% on their exam. So we're going to put 85% over here on the right side of our equation. And now we need to figure out what we need to solve for X. So they have to have at least 85%. So that means that they have to have either greater than or equal to 85%. So I'm going to go ahead and plug that into my inequality, and that's going to give us our equation for this problem. X is greater than or equal to 85% in order for the student to get the scholarship. Let's take a look at a little bit more of a complicated problem. So a factory has a fixed operating cost of $3,600 per day plus costs of $1.40 per product produced. If a product sells for $4.20, what is the least number of product that must be sold per day to make a profit? So to make a profit, we have revenue received needs to be greater than the cost needed to make it. So that's going to give us our revenue is greater than costs. That's very important. Now we need to create an inequality for this. So we already know that X is going to equal our products produced. So for cost, there's a fixed cost of $3,600 per day. So we're going to put that on our cost side. $3,600 per day. And we know that we have to have a cost of $1.40 times X for each product that we're making. So now we've got our revenue is greater than $3,600 plus 1.4x. That's how much it's going to cost us to make these products. Now we need to figure out our revenue. So our revenue, we have it right here. It states that we sell the products for $4.20. So we're going to plug in that $4.20 on the one side. And we also need to plug in X because X is our products that are being produced. So now we have our equation. 4.2x is greater than $3,600 plus 1.4x. So now we need to start isolating for x. So how are we going to do this? Well, we need to get x on one side. So we're going to minus 1.4x from each side, and that is going to give us 2.8x is greater than $3,600. We need to isolate for x. We do so by dividing each side by 2.8, and that is going to give us x is greater than 1,285.71. So if we round up, we need to sell at least 1,286 products in order to make revenue for this factory. The last topic that we're going to talk about is direct proportion and constant of proportionality. On the ATI TEAS, you're going to be tasked with identifying each one of these concepts. We're going to briefly discuss it because it is a very small portion of your exam, but it is something that you're going to need to know. So starting with direct proportion, this is going to describe a relationship where one quantity increases and the other quantity is also going to increase at a consistent rate. Conversely, as one quantity decreases, the other quantity is also going to decrease, maintaining that consistent ratio. So this constant rate is known as constant proportionality, and it's symbolized with the letter K. It quantifies that direct relationship between two quantities. So in mathematical terms, when we're looking at this, the two quantities of x and y are going to be directly proportional. So we're going to use the equation y is equal to kx, where k is that constant proportionality. This means that every unit that increases in our x is also going to increase in our y when it comes to those k units. So I have a little graph down here to kind of help that make sense. So whatever x is, in our first example, we have y equals 5x. Whatever x is going to be, it's going to be multiplied by 5 every single time. So you're going to see this kind of linear equation when it comes to these direct proportional equations. So imagine that you have a bag of marbles. And for every marble that you take out, you get 2 candies. If you take out 1 marble, you get 2 candies. If you take out 2 marbles, you get 4 candies, so on and so forth. This is direct proportion because the more marbles that you take out, the more candies you're going to get. And it's always going to increase at the same amount. In a non-directly proportional relationship, the correlation between two variables isn't going to be linear like we saw with our direct proportional changes. This means that the ratios are not going to change at the same time and consistently. Imagine that you're pouring water on plants. The more water that you pour, the taller the plant is going to grow. But it's not always going to be the same like we have with our predictability when it comes to the candies and the marbles example. Sometimes you might pour just a little bit of water and the plant's going to grow really, really big, right? And other times you're going to pour just a little amount of water and the plants aren't going to grow that much. This is what we like to use in terms of non-directly proportional relationships because there isn't a steady pattern that tells us exactly how much that plant is going to grow based on the water that it gets. In these relationships, variables interact in a more complex way. We typically see y is equal to mx plus b because these equations tend to be more slope-based than we saw with our linear equations in our direct proportional examples. In this case, only if b is equal to 0 would we actually have a direct proportional relationship. So I've listed a couple of equations here on your slide to help you kind of identify the differences between these two relationships so it's easy to answer these questions when you're taking the TEAS. So let's identify the differences between direct and non-direct proportional relationships. So our first example, we have y is equal to 2x. So as we know with our direct relationships, we're going to have y is equal to kx. And with our non-direct proportional relationships, we're going to have things like y is equal to mx plus b. So in this case, we have y is equal to 2x. So as we increase our x, we're always going to have the same number of increase because of that 2 coefficient before our x. So this is an example of a direct relationship. Next up, we have y is equal to 8. Well, we have no variable here, right? It's just y is equal to 8. That's constant. It's a fixed number. It's not going to change. So this is actually going to be a non-direct relationship because we need that variable in order to make that change. Next up, we have y is equal to 3x plus 10. This is a great example of y is equal to mx plus b because even if we increase our x, it's not going to be the same consistently every single time. So because we have that additional term, that 10 on the end. So this is an example of a non-direct relationship. And then lastly, we have y is equal to 5x. So 5 times x, as many times as we're going to multiply something by that 5 with that x, it's going to be the same every single time. So we're going to have a linear equation. So this is a great example of a direct relationship. I hope that this comprehensive video and understanding all things word problems on the ATI TEAS was helpful in your studies. As always, make sure you leave any questions or comments down below. I love answering your questions. Head over to nursecheungstore.com where there's a ton of additional resources that are going to be available to you to help you ace that ATI TEAS exam. And as always, I'll catch you in the next video. Bye!